Okay, just want to throw one more quick little slide or presentation here of some sample problems. And oh, what happened? Well, let's start that again. Okay, there we go. And on these problems, we want to try to eliminate one of the variables. So if you look in here at the first one, that's a 2, that's a 3. Nothing's going to eliminate. That's a 4, that's a 6. So I'm going to have to take both equations times something to get a variable to eliminate. So you know what I'm going to do? I'm going to take the, our choice. We want to make basically like a common denominator. Do we want to eliminate the a's? If so, we want to change that into a 6. If we want to eliminate the b's, we got to change these into a, what would be 12. So your choice. What would you want to change these? The a's into 6s or the b's into 12s? And I think it's a little bit easier taking the a's, making them into 6s. So I'm going to take the top equation times 2. That'll make 6a there. Then the bottom equation, if I want to make this into a 6, it has to be a negative 6, so they cancel. So I'm going to take the bottom equation times negative 3, and that'll make it a negative 6. So watch with me. So once again, top one times 2, bottom one times negative 3. So I get 6a minus 12b equals 12. Bottom one becomes negative 6a. See how they're opposites? And they'll eliminate. Plus 12b equals negative 12. Okay, so go ahead and add those two equations together. My a's eliminated just like I wanted them to. My b's, oh my goodness, my b's eliminated too. So since they both eliminated, that means I have 0 on the left-hand side. Let's see what happens on the right-hand side. Right-hand side, I've got 12 minus 12. That's a 0 as well. So I have 0 equals 0. Since my variables canceled, and I'm left with a true statement, 0 does equal 0, that's going to be infinitely many solutions. Infinitely many solutions. Do you know what that means graphically? Well, if I was to graph both these equations, and I'm just going to quickly throw a sketch on here. The x-intercept, I'm going to say x and y, a and b, same thing. X-intercept was 2. Y-intercept would be negative 1. And draw the line. Now look at the second equation. I'll do that in black. The x-intercept is 2. Y-intercept is negative 1. Oh my gosh. So it's the same line lying directly on top of itself. So if that's the case, you get infinitely many solutions. That means the two lines are crossing infinitely many times all over this graph, up and down it infinitely many times. So that's what happens when they both cancel. Now what happens if this was like 18 and this was negative 12? Well, then I would have had 0 equals 6, and that's not true. That means it'd be no solutions. That means I would have had parallel lines, and so they never cross. Okay, so those are the two situations that can happen if your variables cancel. Let's do one last one over here. I just want to change the colors. I want some blue. There, that works. Okay. Boom, boom. Okay, so we either want to change these to a 28 or these to a 6. And notice 6 is going to be easier. But another reason it makes it easier, this one's already negative, this one's already positive, so you won't have to do anything with the signs. I'm just going to take top one times 3, bottom one times 2, and it should be set. Let's see. Let's go fast. 12x minus 6y equals 48. Bottom one, 14x plus 6y equals 30. Okay, the y's cancel just like I wanted them to. 26x equals 78. When I divide 78 divided by 26, I should get x equals 3. So there's my x value, halfway there. Plug the 3 back into one of the originals. Looks like this one looks just as easy. So I'm going to go 21 plus 3y equals 15. And I did the bottom just because I'm sure most people do the top, but I wanted to avoid the negative. So subtract the 21 over, that makes negative 6 over here. Then divide by 3, so y equals negative 2, and there's the spot where the two lines cross. You should be able to finish pretty much everything in your packet from this point on. We'll talk to you soon.